Okay, so I had a student asking me about this problem. I thought I would offer a little help. I'm not going to do it for you, but I'll offer a little bit of help here. We're going to have to use trig. That's the key. And we're going to have to think about which trig functions to use. So we're going to find this length right here using this triangle. And then we're going to find this length using this triangle. And note that we have corresponding angles there. So this angle here is also theta. Okay, so you've got this triangle right here. That is a right triangle. We're assuming this wall was standing straight up. This is theta. This is 16. Let's call this H1 for hypotenuse 1. You're going to have to figure out what trig function you could use that would relate these guys here so that you can write H1 as a function of theta. Not H1 times theta, H1 as a function of theta. Then we're going to build this little triangle here where this is 4. This is again theta. That angle right there will be theta. And we'll call this H2. And again, you'll need to figure out what trig function to use there so that you can write H2 in terms of theta. I'm saying here H2 as a function of theta. Then the total length as a function of theta is just add those together. Oops, H1 plus H2. And there are a couple of different ways you could do it. My suggestion would be, like, just as a hint here, you may look at this and think, oh, sine would be opposite over hypotenuse. I really don't want hypotenuse in the bottom. So maybe think of a different trig function that would keep h on top for both of these. I wouldn't use sine and cosine is what I'm saying for these. Then the rest should be easy. You're going to take the derivative, set derivative equal to 0. You're going to have to solve a trig equation, solve that. And I think that's a good place to stop.